I see some familiar faces. Eugene, we got and let's see. Hey, buddy. Sahun, is that the Sahun Choi I know? There may be many, but if you worked at Cray, then that's the Sahun I know.
Hey, Samuel Reswick.
Yeah.
Please make me co-host.
You should be a co-host now. Yep.
Okay, feel free to get started.
Cool. Yeah. All right. So great to see everybody. See some familiar faces. Chip asked me to come and give kind of a a little bit more in-depth version of my large language models and production talk on vector databases and LLMs. And so I wanted to do that. And she asked me specifically to kind of go deeper into some areas. So you'll see if you saw that, you'll see I'll talk about a little bit different content, some different examples, some design patterns, some trade-offs and considerations in these types of architectures, things that I've gleaned from deploying this for people and set it up and actually running through these use cases. So without further ado, I'll get started. Oh, and host disabled participant screen sharing. Classic. Can we give me permissions there? That would be wunderbar.
Yep. 1 second. If Zoom would work.
It often doesn't.
Could you please make him co-host?
Yeah, I'll do that right away.
And before Sam Partee gets started, let me do a quick intro. So Sam is the staff engineer at Redis, and he's been very, very active around and get involved in the LLM space. And as we all know, there is this thing called memory that's usually used and required in building large language model applications. And Sam today is going to introduce us to some of the nuances and challenges in doing so. So, yep, Sam, you
Awesome.
have co-host now.
Thank you. Yeah, no, so great. Thanks for the introduction. You already know me, so I'll just go ahead and get started. Got about 20 slides, so I'll get through it probably in about 30 minutes. And we'll be able to take some questions hopefully afterwards. I don't know. But where I always like to start is kind of the top. So what are large language models? Most people at this point are familiar with them. Most people have used them. Most people have at least interacted with them through ChatGPT. And it's this long train that we've had from the very beginning of everybody remembers the MNIST networks that we used to build back when TensorFlow was actually a great framework to use for building these types of models. Nowadays, you don't even build your own types of models. You just go and get one of these variants that you see 3 of them listed there, and then you take them and apply them on your task. And it's been interesting as someone who came from high performance computing, where a lot of large models were trained, to now this space where essentially no one's really creating their own models anymore. It used to be, I worked on Determined AI, if you remember, that platform bought by HPE, now part of that different, machine learning offering that they have. However, back then it was much more, I have this problem, whether it was CV or it was, something in NLP, and you were building a model specifically to address that task. Well, nowadays there are many more options. And actually, I feel like the bar, and this will be a consistent theme throughout this talk, the bar for utilizing these models in production has actually lowered dramatically. Now, that doesn't mean that it's easy. And that doesn't mean that there aren't trade-offs and things to consider in these architectures, But the bar on which these types of models can be used to make something like a product in this space has been lowered from that point at which you said, I have a lot of unlabeled data. I have to go through all of that data work process, all of the model building, model variations, model tuning processes to then use that in a product. So now the bar is much lower. And so you see some of those listed here, but one interesting aspect of these models is that they're not even large enough. And I like to say that because it's kind of funny that they're called large language models, but at the same time, they don't always include everything they need to accomplish a given task. And that's where this concept of vector similarity search and vector databases come in, which would be a theme throughout this talk and something that I've been doing explicitly over the past 2 years and really focusing on. And some of these use cases you see there, we'll go through a bunch of these, specifically that last one and its variants and how it can be used. And we'll also talk about some of what you see there on the left. Large language model providers, closed source versus open source, application development, what frameworks should I use? What, you see Jerry just raised 8.5 for Llama Index to become a real, product essentially besides the open source. And this space is exploding, and there's a reason, and it's because of how easy it is to actually create these really powerful new products with these off-the-shelf models. So that's a quick summary, but really now I'm going to focus on that vector similarity search and that side so that I can introduce the vector database topic. And then I'll talk about how they're actually used together and then talk about kind of going to production and some examples, okay? So I like this slide. I've shown this probably in 10 different talks now, but it's important to actually understand what a vector embedding is, where it comes from, what it does. They are representations of unstructured data. And the way I like to say this to people who aren't familiar with this space is that they're just a list of numbers. Everybody remembers, fourth grade or whenever you took geometry, right? SOHCAHTOA. Well, that's essentially, once you have one of these vector embeddings, the most complicated operation that you're usually running is something in that space. Vectors, no different than they were back in the school days when you had a direction and a magnitude. Except for now, the number of dimensions in that vector is 15,036 in the case of the OpenAI models. And so these models can take in audio and text and images and videos and whatnot, and they can create vector embeddings that are representative of that unstructured data. What I like to say sometimes is also it's anything that's not in an Excel spreadsheet. So anything like an image or audio or text that's not necessarily what's built for an Excel spreadsheet. And these are packed with information. So they're highly dense most of the time. Sometimes there are sparse vectors, but they're usually dense vectors where each number truly means something. And when I say mean something, they mean something in relation to another one of those representations, one of those vector embeddings. And so when you compare them, the comparison operation, despite being such a simple operation that you did in third grade, is actually a really powerful operation because each of the numbers in the list means something really important. Everybody probably at some point has gone through a CNN tutorial where you start to see that the edges and thinking about MNIST again, the edges and the curves of a number are start to get bucketed successfully again and again into smaller and more important features. Well, or larger, depending on how you rate your model. But in this case, those same attributes of what's in an image, what's in text, what have you, is present in that vector embedding through these dimensions. And as I mentioned earlier, these are really easy to create now. So you have Hugging Face transformers, which on the right-hand side, if you've done a tiny bit of Python in your life, you can create vector embeddings. Import, pick a model, have some sentences, and encode them. And then boom, you have your vector embeddings. So I show this one a lot as well. You've probably seen this. I overly simplify this example. So this is not accurate, but if you didn't realize, you can't necessarily visualize 15,036 dimensions. So you always have to do some type of reduction into a space that actually you can see. This is completely oversimplified for the purposes of the demonstration. But in this case, we have a search space of 3 semantic vectors that you saw me create with the Hugging Face model on the last screen. And those 3 sentences, the goal here is to say, if I have some query sentence, some query vector that I've also created, I want to compare that vector to the rest of the vectors in my data set. And that's what search algorithms do. They are data structures, essentially, that allow you to efficiently search over a large number of these vectors. You've probably heard of some like HNSW, hierarchical navigatable small worlds, that allow, it's essentially a tree-based structure in some ways, that allow you to efficiently search through a highly dimensional space very efficiently. And so when you use something like cosine similarity, calculating the cosine angle between those vectors, you can see then that you are able in really that's the similarity that you get. It's 1 minus that, or that's the distance that you get. 1 minus that is the similarity of those vectors. So you see that 1 minus that is a very happy person is 0.943 to the query sentence that is a happy person. This might make sense, and you might think that BM25 can actually do the same thing. But as soon as you look at that as a happy dog or today is a sunny day, you start to realize that even though there are other words present in that sentence that BM25 would pick up on, the semantic meaning of that sentence is significantly different. And that's also something that's going to come back through this topic, is that each of those dimensions, they're more representative of what's actually in that sentence because of that model and the vector representation that that model creates. It's been trained on all of Wikipedia and all of Reddit and all of, whatever the data set that OpenAI and everybody else is collecting to actually pre-train these models. And in this case, all of that information is used to pack this vector with information about, what that text actually says. And so just like ChatGPT can understand certain things about what you put in that text box, so too can these vectors represent what you put into that model and hence that vector that it creates. So I always point out this one because I wrote a lot of really simple code just using NumPy and whatnot to actually calculate the vector similarity. If you want to go check it out, it's the MLOps community page. Also, Chip has some really great stuff on this, so check out our blog. So what is a vector database then? A vector database is essentially, you can imagine those same data structures that I was talking about for efficiently searching, plus CRUD operations. And in some cases, not even CRUD operations, but usually fully supported CRUD and database-like features in addition to some type of secondary indexing or data structure that allows you to efficiently search over said vectors that you store. I worked at Redis and helped run the vector database unit, which essentially using Redis search helps make Redis into a vector database. So you can store vectors in hash or JSON alongside like other text, numerical fields, geographic fields, etc. And you can do interesting combinatorial searches between vectors and all of those other fields. So you can do this, as mentioned, with any type of these models that are now off the shelf, I like to say. And I'll get into a little bit of this, for when to use what providers from what we've seen in the field. But really, if you're doing something like putting together a demo and just trying this out yourself, it really doesn't matter all that much. Now, if you're deploying this in production and you're going into like having a really powerful search, we'll get into how to actually go through some of these various things that are really important. I'll point to some resources that we've made in conjunction with OpenAI that will help out. So that is essentially what a vector database is. It organizes all of these vectors into that indexing methods that I mentioned earlier, and then also provides the CRUD operations to be able, in the case of especially of Redis, to be able to change them and index them in real time, such that you can deploy them safely and comfortably as an engineer into an application. So I'll talk a little bit about this and I'll move on because I don't want this to be an ad, but we have a bunch of integrations now, as you probably saw. My team's done Llama Index, Relevance, Gene and Metal, LangChain, and OpenAI retrieval plugin. We have more on the slate. One thing that's coming through is you'll probably see an open PR for Redis search to add the Raft-based indexing from NVIDIA. We're working with NVIDIA. Jensen announced that at GTC. And that will be a really cool new indexing type that will actually run on GPU. So if you're interested in that and you have a use case for a really high scale, really fast, really high throughput database that has this capability, let me know. Interested in doing some pilot projects there. But we have a bunch of different distance metrics. And when I say hybrid queries here, for those of you who know what a hybrid query is, really what I mean is filtering, pre and post filtering of a recall set. So you can do things. We have had Redis search for a really long time, text, as I mentioned, numeric fields, text being like full text search, geographic, range, etc. And you can use those in combination with vector search. And then also new in 2.6, you can do this in JSON. All right. So now for the interesting part, that's not just about Redis, some design patterns. So things that I've seen in the field or that we've deployed for, and obviously deployed and generalized so that we can talk about it. But things that we've seen people do that we consider interesting for this type of talk. So I'll talk about 3 specifically here: context retrieval, large language model, memory, which might seem a little interesting, and then caching, and specifically semantic caching, which is a really interesting new way to use vector databases, especially one like Redis. So context retrieval. In these things called Q&A loops, it might actually not be a chatbot. It might be something like, say document retrieval. But it all kind of looks like the same loop. The point here is what we're doing is we have a vector database set up ahead of time where we've taken some number of documents or images or what have you, usually some piece of text and some body of text. And we've broken those up into specific vector embeddings that represent that text. We've then indexed those in a vector database and then created a framework around that vector database to be able to ask a question, embed that question into a vector embedding, use that to look up in the database what's relevant context, and then construct a prompt with all of that information that we've retrieved from the vector database. One really interesting thing about Redis here is that it actually allows you to do this in the vector search call. We'll get to this when I start talking about other vector stores, but essentially a lot of stores or a lot of platforms right now, they have separate metadata. And what's really crucial is to store metadata and vectors in the same place to avoid network latencies. And because think about it, if you are searching through something, you don't want to wait for, say you have 1 million documents that chunk up into 5 million embeddings. You don't want to have to wait a really long time to search through those 5 million embeddings just to retrieve the context for a large language model that's already possibly going to take 5 seconds, 10 seconds in the case of some of the GPT models of the network. So storing that metadata in conjunction is really important. So in this case, if we have a hash or a JSON slot, we can store text and a vector embedding, that semantic embedding that represents that text in that same data structure. And then when we do a vector search, we ask for those text fields back. By getting those text fields and doing the vector search, we can then put those text fields into the prompt that we pass to GPT. In this, this is, something like what, LangChain was facilitate or some other frameworks like Relevance AI. You can then construct a prompt that answers that question with context. And so there's a couple really important parts here that might not be obvious if you're not familiar with vector databases. A lot of people talk about fine tuning. There are cases where fine tuning still may be needed in this kind of loop. If the text isn't, it's out of corpus or it's, there's a couple other reasons why, but specifically here, this is much cheaper and faster than fine tuning a model. And what I mean by faster here isn't necessarily the process, the offline process, but the online process. If you have to go and retune your model, which would be insane for you to do in production regularly, then you're going to be incurring a lot of time. So in this case, and there were people that were doing this before this was a popular approach. However, right now, instead, you can just update the vector embeddings in the text we're in or add to that corpus. And then you have new context immediately, which allows for real-time updates. So in the same milliseconds that you would have stuffed something in your cache, you can now also update a vector embedding in that index, and then that text with that embedding. And so if you get a new document or if you get a new answered question in a community, or if you get a new any piece of data that comes into your data set, you can update that index and that piece of text in real time instead of having to wait for a model change, A/B rollout to be done. So the last thing here is also sensitive data. This is a big thing. Work with a lot of enterprise companies, and a lot of enterprise companies don't feel comfortable making a model that they don't know will output something sensitive. So instead, you can do context retrieval. And in that context retrieval, you can put in rules for specific pieces of data. You think about like role-based authentication control, RBAC. You can have roles that essentially are privileged for various users to see different context. And that model beforehand knows absolutely nothing about that sensitive data. So there's no way if you fine tune your model for you to guarantee that it's not going to say something about that sensitive data. However, if you do it in the context retrieval loop, you can guarantee that. The last thing I'll say here is also about hallucinations. So that's a really big topic right now. Vector databases can be used as a sort of guardrails. They can say, oh, if I retrieve no context, what do I do? I actually just did an LLM stack hackathon with some of the people that were actually probably in this year's Zoom. But one of our judging criteria, Chip and I, when we were judging, was how well does it deal with hallucinations? It's something that we see in production with a lot of these loops, whether it's Q&A or not. Models love to make stuff up. They do. And one way to stop them from actually making something up is to tell them when not to. They're instruction-based models. So if you instruct it, if no context is retrieved, to not say anything or produce an answer, as you probably see GPT does all the time, or ChatGPT rather, then you'll see that's actually how these vector databases can be used. So there's some use cases we'll talk about here, and I'll actually give a couple of those. But if you want to go check out a couple examples of these, everything I'll be talking about today is on Redis Ventures. That's our GitHub for my team. That's the applied AI unit. We are running out of things to slap on the end of Redis, so we thought Ventures sounded cool. All right, so long-term memory. This was actually a project that we interacted with quite a bit. It was outside of our group, however. It was really interesting, so we wanted to see kind of what was going down with them. So in this case, there's a finite context window, and I know some people might say, oh, but Anthropic has a 100K token context window now. Well, even if you have 100,000 tokens and you are trying to build something like, say, for your ML learners Slack group, right? Where that Slack group, every single message within it is actually a vector embedding, and you will have the text associated with all of it. Eventually, you run into the point where you can't just stuff everything into it. Not only that, but that all of that might not be relevant, and it might confuse the model into thinking that it is. And so instead of going to the approach of, well, just stuff everything inside, it's let's find the most relevant pieces of information to actually put inside of the database. And so in this case, what this long-term memory approach does is through conversations, it's able to actually pick out and decide which pieces of a message history are actually relevant to the conversation. This allows you to do things like topic changes, logging off, logging on, continuing a conversation, and having those previously relevant pieces of information returned. Imagine if you are building a bot for TripAdvisor, or you're building, for Expedia or something. You could then type in something about going to the Bahamas and then start talking about a trip to Germany. And it wouldn't then use the context of your trip to the Bahamas like some approaches would that are out there today that just use your entire previous message history in that session. Instead, it's going to go and look up every single vector that's relevant to that particular message, and instead pick those pieces to then have a conversation about. And so then you could go right back after talking about Germany, you could talk about your trip to the Bahamas, and it would not be confused, to pick out the relevant information. So this is approach called long-term memory, since you can hold significantly more vectors in a vector database than you can a context window, even for Anthropic's. I think it's Anthropic's models. And this is useful for a number of things. Think about information retrieval as well, not just chatbots. And now a really cool one. So one that we've actively been working on, but it's called semantic caching. And so you can think of, let's talk quickly about caching. What does caching do in general? Let's say you have some web page or some query, and you say you're in Salesforce and you're looking up a number of companies or something. I don't know, not in sales, but essentially, if you have some list of companies that you had to compute based on some query, you wouldn't want to then go immediately run that again. You would want to take that query and the result associated with that query and hash it such that you can retrieve it just by an O of 1 hashing and retrieval in a key value store, something like Redis. Now, that only returns that value in the case where the query is exactly the same, because a hash is an explicit hash of that text, and it's not meant to have collisions, right? The whole point of it is that it has to be the exact same. Well, what if you had a really similar query, like say it has a similarity score of 99%, and the answer is going to be the same, but it's not going to hash the exact right thing because a user maybe put in a question mark and then the other one didn't put in a question mark or something like that. It won't be the exact same. That query is not the same text, so it will not hash to the same slot. Well, what we've been looking at is how can we take this concept of semantic search and apply that in a caching sense. So what you're going to be able to do, and you can do right now, by the way, there are people doing this and in production. We're just looking at making it easier, is essentially be able to do a vector query for your cache contents, set a threshold for how similar can something be here, and what that, or to the point where it's not necessarily looking up explicitly the same thing, but how similar can it not be, and say still return that same answer. And what does this do? It saves computational costs. That's one of the big things. Every time you do one of these lookups, you create an embedding 0.002 cents if you're using OpenAI and Ada. And then also it invokes an LLM, which, depending on the model you're using, may be somewhat expensive. And so you're going to save on costs. And so we've seen people deploy it and immediately start saving money, because the truth is people say the same things. People ask the same questions. If you're building something that answers questions on a website, the truth is you're going to get a very similar question from time to time. And so you're going to returning the same answer is actually even better. Some people even go as far as to pre-compute a lot of those questions that they expect to get, and then set a similarity threshold and have tests for when particular questions are of the same nature. And this is something that you can do ahead of time, and then instead of actually relying on the users to populate, you can pre-compute a lot of those answers and then speed up your service overall and save costs. The first part I said there is also really important. When you return something from a cache and you do a vector query, in the case of Redis, you're looking at milliseconds, or in some cases sub-millisecond latencies. That is significantly faster than a large language model. Almost every one, I can guarantee it, because they're slow. They're really large. They move slowly. They're lumbering giants. And in that case, you're not only saving on costs, but you're speeding up your service, which is kind of the whole point of caching in the first place anyway. And what does this apply to? Well, pretty much every single LLM use case, which is actually really nice, because there's a huge need right now to reduce the costs and increase the speed of these types of architectures. So it's a really interesting space to be in. So let's, speaking of which, talk about some architectures that we've seen. And these are just some considerations. So I talked about this. What about what providers? How do I choose a provider? How do I choose what model? Is it open source or is it closed source? Do I have the actual model itself, or am I picking an API? Do you use a platform or do you roll your own? Do you take a small model and fine tune? You see a lot of progress right now being made instead of using these really large models, taking much, much smaller models and actually fine-tuning them for a specific purpose, and you see them outperform even some of the largest models. And it's hard sometimes to discern when to do one or another, but a lot depends on your application and your use case. So if you need really high QPS, low latency, you may think about doing something like that. But if you need the utmost flexibility and your team is really small and you're not machine learning experts, you may rather choose that API. What's the enterprise readiness of this? Has this model been, given an SLA? Like, are you using something off the shelf? Are you going to get rate limited? Those are all things to think about when you actually take something to prod. That's what we call enterprise readiness. A little bit buzzy there. Costs too. So this is a tough one. If you host, a Hugging Face model and you're going to put it on Triton and then put that on a G4 instance in EC2, did you chart out the cost of that infrastructure rather than just pinging OpenAI? Because they have. And there's a lot of times in which it's cost advantageous to do that. There's also times it's cost advantageous to just use OpenAI. And so cost is actually a really important dial here, because sometimes, especially with semantic search, you don't really need really good embeddings. The better the embedding, obviously, the better the search. But for some use cases, that's not really necessary. Sometimes it's used as a backup strategy to BM25 or TF-IDF, like text search. So that's an interesting thing to consider. Scale and performance as well. How much does it cost to host model replicas? How much does it cost to scale out those replicas using something like Red and Hans T-shirt right there? And what is the performance of these models in terms of QPS? Thinking through all of those things when you go to set up these architectures is what I do on a daily basis. And I tell you, it completely depends on the use case. And everybody wants to do something different. So it's interesting to see how different this space is, rather than something like, say, normal database usage, where it's pretty much just like, I need a fast one, choose this. I can afford it being slow and relational and use this, or something like that. There are a lot of different things to consider in the space. Including integration providers. Can you trust that these providers that are being put out are not going to change so quickly when you go to production that something's going to break if you update your version there? And so strategies that have been in software engineering for years, like A/B testing, are still really important, or even more important in some of these cases where this space is so quickly moving, releases are happening on a daily cadence. So I talked about infra costs and model time, dev time. One more interesting point here is the kind of large language model providers themselves. They are somewhat different. If I'll show an example later, but you can go to it now and play with it if you want. It's https://docsearch.redisventures.com. And it is a interesting demo because it has 3 sets of embeddings, 1.2 million in total. And it has a Hugging Face model. It's all MLP-net one. And then it has Cohere and OpenAI. And each of those do something better than the last one. They all fail in different use cases as well. Like, for instance, if you use the Hugging Face model and type in a query, it may do very well. But if you translate that to Portuguese, you'll see completely different results come up. Now, if you take the OpenAI model and you do a query and then you translate that query into Portuguese, you'll see it does fine. The semantic meaning behind languages is slightly different, but you'll see that actually the OpenAI model does pretty well. The Cohere embeddings that we used aren't actually their multilingual embeddings, but we have used those as well. And those are probably the best for multilingual use cases. I think it's like 1,500 languages, including like dead ones. I think like Latin's also included. And that includes non-Latin characters and things like that. It actually is really, really powerful for situations where you don't want to build a search service for every single language. And so that is also a super interesting piece of this, in that you're not needing to put in a translation layer, and things and use cases like that are important to consider when you're choosing what model you're going to be using for these use cases. Also really important is performance of the vector database. So Eric Bernhardsen created Annoy at Spotify, and it is a driving factor of a lot of the ANN activity that goes on. And one thing you'll see on the Eric Bern's GitHub, Eric Bern, that's ERIK BERN, in his ANN benchmarks repo, is a comparison of a number of these different platforms and algorithms, not just databases, just pure algorithms. And how these databases in the terms of approximate nearest neighbors are actually benchmarked is queries per second for recall. And the reason being is, if you have a KNN, obviously your recall is perfect. If you have in this case, if you have an ANN, you have a lot of tuning knobs. What's your in the case of HNSW, what's your in parameter, what's your EF construction, what's your EF runtime? All of those that you see in the HNSW paper, they all matter to determine what your recall is and what your QPS is. In this case, this is a single CPU benchmark where they test the QPS for recall of a number of different platforms. Just to shout out, because obviously I work there, if you see Redis search is the purple one here. In terms of the far end of recall, the three that are above us are essentially algorithms. So things like scan that you see here on the top, and a couple other ones like I think it's PyDescent or PenDescent, which is this one, I think. We do fairly well in terms of QPS to recall. That's honestly because Redis is built as a cache originally. I mean, it's really a database that was popularized as a cache, key value store popularized as a cache, but it's very fast. So QPS, queries per second, is something that it has an advantage over in a lot of cases, but it all depends on your scale. If you have 10 billion embeddings, Redis probably isn't your database of choice. You probably want to use actually something that's not a database if you have 10 billion embeddings, because otherwise you're going to be paying up the nose for it. You probably want to use something like PQ, IBF, FICE, or something like that, where you're going to be able to condense that vector space into a really small area. And what you'll do is simply have, I've done this before, vector databases were a thing. You have like a Lambda function that loads it from S3. And every time you call it, you just call the Lambda function and it's loaded up if you called it in the last 300 seconds or something like that. There are times and places for everything. And so just because QPS recall is important doesn't mean it's the only thing. And you should consider this when you're setting up these use cases. You shouldn't just go, oh, such and such is the best, so we're going to use it. There's times and place for everything, and all of those things that I mentioned that were important about models are important for vector databases and which one you choose on, in the same way. So I'll go through some of this, and this is a very quickly changing space. So if I left someone out that's like, but I made my vector database yesterday, please don't, come at my neck. I tried my best here. And this is a lot to research. You'll notice that everything is skewed to the right. That's because not a lot of stuff is proprietary and or self-managed. There's only two in that category, essentially, Pinecone and GSI technology. We'll skip over those and we'll go right to the new players. So in open source and in kind of the managed versions, okay, you have a bunch of new players. You have Chroma, which is based on the columnar store ClickHouse. You have Quadrant, which I think is based on Rocks, and Weaviate, Bob's company, and Milvis, which has been around for actually a long time, and Vespa, which is probably one of the better pure search vector databases, Vald and Supabase. Supabase being based on PG Vector. Actually, one quick thing I want to point out, just so that everybody realizes it, why I sometimes take fun shots at PG Vector on Twitter is because if you see here, PG Vector has some of the lowest QPS to recall in the game. As I said, that's not that important for every single use case, but it's an important thing to point out that if that matters for your use case, you should know. And so do your research and look up what you know. So going back, bunch of new players, okay? And honestly, a lot of them are great. And a lot of them, just like anything, have trade-offs. There are also what I would call the incumbent databases, because right now these are essentially vector search platforms, some slightly different like Superbase, but these are essentially vector search platforms that are becoming better databases. Superbase obviously being a little different here, but all of these were, they weren't necessarily making a database. They usually wrap something like ClickHouse or Rocks, and then they became better databases over time, or they're becoming better databases over time, versus this category, which are databases that are kind of becoming better vector search platforms. So there's an interesting dichotomy between the two. And that is something that should be considered when you're actually going to production with these kinds of things. There are a number of trade-offs that are encountered. Like, for instance, some of these platforms have PQ, product quantization, which makes your vector embeddings much smaller. They maintain a cookbook, and they're able to translate those embeddings into much smaller memory-consuming versions of those embeddings themselves. And that's really important. But then, they might not have something like, an on-prem version that can also active-active replicate to something like a cloud version, or they might not have, a number of different deployment options or, hosting options, or other features that may be important. So I'll go through some of those considerations right now. You have team sizability and budget. That's kind of the first and most important one. It's important because if you don't have a large team and you don't have specific ability in the space or a huge budget, you may not go for something self-managed. You might want an easy to use cloud platform. You just kind of click to deploy, have it load up for you. There's a number of options there for that. But then, if you get into budget, there are going to be some that sit lower on the cost spectrum because they may be newer, and then some that sit higher on the cost spectrum because they may be more established. And so you have a dichotomy there as well. Performance, like I mentioned on the last page, there may be many use cases, not to pick on PG Vector again, where PG Vector is completely fine, and it's in the QPS recall is totally okay for your use case. But if your use case needs a better QPS to recall, or even one of the other pieces of performance like pure latency, then you may consider a different option. And so it's important to also bring that to mind when you choose what platform or search algorithm you're going to use. Capability. So think about something like Feist. Feist doesn't have hybrid search. It doesn't have like a filtering of the recall set. It's just a vector search platform. So yeah, you might be able to put 4 billion embeddings in it, but maybe it'd be better to actually do a smaller number of embeddings that also have an ability to filter all of that pre or post recall set, which are offered by many of these. Like Elastic has their pipelines. You might need to run some type of inference if you're building some type of, say, recommendation or search service. You might need to run some type of post-processing or some type of other feature that's not available if you're just using one of those off-the-shelf search algorithms. You may need that capability in conjunction with whatever you're using. You may need more database-like capability, like replication, so that you get high availability. Those are all things to consider when you're actually choosing what you're going to use. You may want to look under the hood. You may want to also have pure CRUD. You may, some of these, like I mentioned, Feist, you can't, and some of these services, by the way, are wrappers around Feist. And so, or custom variants of Feist. When you have something like that trains on a group of embeddings, you need to consider the fact that when you add a new embedding, you essentially need to retrain. It's not necessarily training, it's more of a fit or a transform, but you have to create that vector space. That's what allows for a lot of optimizations, but it's not really pure CRUD. You're not taking in, taking out. Whereas something like HNSW and people that are vendoring or taking that into their libraries, you are able to essentially prune parts of the tree and actually perform more CRUD-like operations. Obviously, with a flat index in KNN, it's much easier. Think about it like list operations. Integrations. Does that Does that platform integrate with your favorite, integrator? So something like LangChain. Well, you might need it to. So that might be one of the decision-making things right there. You might need it to have a ChatGPT retrieval plugin. If it doesn't, you might not be able to use it. You may want to be building more of the platform yourself. Use something like Llama Index or LangChain or what have you. You may want to build a little bit less and need more quickly, made functionality. Use something like Relevance, or even further, if you want to, or in this case, like Metal, for instance, is a more, I would say it's even lower. It's between Relevance and like a LangChain, where it's really just like a managed version of a vector database, such that it's really easy to get started, but you're still developing that yourself. It's not really performing that integration layer. And then going up even further, you have things like, you have the Mantiums of the world that, are doing a lot for you. They have their own retrieval plugins. They have their own platforms that are doing specific things. And I think what you'll end up seeing in this space is a proliferation at the high end. So people doing more and more at the highest levels of abstraction. So going up even further in the stack and saying, this is the best one for this particular use case. And that proliferation will get even stronger, I think, as we go on. And the last one I was going to talk about today is also deployments. Do they have like a K8s operator? Do they have Helm charts? Are you going to be deploying this yourself on K8s or EKS or something like that? Do they have people that have deployed that before? Do they have offerings on every cloud marketplace? Do they have HIPAA compliance? Do they have FDIR or whatever the other one is that's for financial people? As you can tell, I'm not a compliance person. Those are all things to think about, because what you don't want to do is start your startup, get a ton of jazz, get a ton of funding, and then realize that your whole architecture needing to be compliant suddenly relies on this platform that cannot provide that. We've seen that a couple of times. We've had people that have, essentially foot-gunned themselves for that exact reason. And, they come to Redis and they go, do you have this? And we're like, yeah, we do. We're 15 years old. So that's another thing to consider. But that's also, again, not everything. All of these considerations matter and more. There's a ton of things to think about when you're actually choosing this architecture and this setup. So everything from model to the database to the way they communicate to the integrating layers, all of that matters. And it's all going to change how your application performs. So now just to talk about this, let's go through some use cases. This one's pretty easy. You'll see some examples of this on Redis Ventures, but I talked about this one because it's fun. So we have there's another version of this. It's not quite as cool as this, but it shows you how vector search works. It's ecommerce.redisventures.com, node dash in e-commerce. And so you take a bunch of product reviews, descriptions, what have you. And this is actually really powerful. It almost feels like it shouldn't be this powerful, but it really is. Even if you go on Amazon, you just scrape all the descriptions of products, which may or may not be legal, so don't hold me to that. But if you do go and do that and you scrape those descriptions, those text embeddings are actually really good at providing a user search service. As I mentioned earlier, that's not everything. If you're going to go deploy this as an actual search service in production, you should go look at Colin Jarvis's notebook on OpenAI. It's in the OpenAI cookbook and apps, and it's the enterprise search. You'll see how he implements things like re-ranking and whatnot that actually allow you to have like a true, more enabled search service. But even off the shelf, it'll make for a great demo. If you have these reviews and descriptions, create these semantic embeddings and index them in something like Redis, doesn't have to be. You can create an application backend that also communicates with GPT. So say we're using 3.5 Turbo here, we can take those vector embeddings, retrieve context, and chain them together with something like a LangChain. That's an integrating layer. We can then provide that Q&A loop that we talked about to provide a chat dialogue from the same backend. And this will look a lot like you see on that website that I mentioned. This allows users to say something like, I would like a stylish white-collared shirt with a pocket. And so in this case, if you go and you look this up on a number of different search services or your e-commerce platforms, this doesn't return many good results usually. Sometimes search services are a little bit better, but saying this in natural language like this, where you're saying, I want a blank, a blank, a blank. Oh, look at the cute dog. There's a cute dog in the Zoom if everybody hasn't seen that. But you can say things that are more indicative of how you would speak. And so imagine just talking to your phone like Siri, which I imagine has to get better very soon, will be something like, hey Siri, order me a stylish white collared t-shirt with a pocket, size 36, yada, yada, yada. You're not clicking through a GUI anymore to say, I want a medium, I want this, I want this, I want this. Natural language will actually be able to do that filtering. It will be able to pick that out, do that filtering, and then actually select a t-shirt or in this case, a collared shirt that will actually represent what you said. And so in that case, doing that loop, looking up those embeddings, generating that response, and actually looking up those products, you can provide not only a chatbot-like experience, but also send back product numbers, product links, build an affiliate platform if you would like, make some money on it, and actually return that affiliate link and make some money. So that's just one example. I've actually seen someone make this, and they're going to make it a product. It's obviously more involved than this architecture shows, but the point of this is to explain it. So this is also another one, a very popular example right now. This one was actually made by a guy named Fabrizio, who's a GBB, a global black belt, which has always been something that I find interesting that Microsoft uses to say that someone's really good at programming, because karate doesn't have anything to do with programming, but that doesn't matter. So in this case, you could take your knowledge base, which are essentially in this case, PDFs, documents, texts, what have you. And in this case, instead of using something like Llama Index, we're going to be using all of these Azure capabilities. And so you can see form recognizer, translator, and then the Azure OpenAI service. Satya was smart enough to get 49%. So he's able to host these models in Azure. And then, Redis is actually a first-class platform on Azure as well. So you can use the Azure Cache for Redis Enterprise, aka Acre, and you can do so and deploy this whole thing either on Redis Stack on your laptop and just put in your Azure credentials, or you can actually deploy it in Acre itself. And that same loop that we talked about earlier with OpenAI models, you can do completely on Azure. And so in this case, instead of returning products and having that chat experience, we're returning documents. And you can implement things like this. We talked about long-term memory or semantic caching. In this case, both of those can apply. You can have people look up the same documents. You can have people return the same query. And then you can also have people that over time, think about how many times you've looked up the same thing in a Slack search or another service. But maybe you have a slightly different variant of it this time. In relation as well, you may be hoping that you can chat with this service and have it remember those specific conversations at a later date without confusing the most recent context with the most relevant context. All of those design patterns I mentioned before apply in both of these examples. And so even though these are two relatively lightweight, I would say, examples for what you can do, it is still an incredibly powerful system to be able to put into production. And that's really possible because of this intersection of large language models and vector databases. So that's it. Thanks.
Awesome, right on time. I was just about to give you a time check.
Nice.
Nice. So yeah, we have a whole lot of questions. So we'll see how much we can get them answered. And I don't know how much time you have. Yeah. Reswick, do you want to get started on the Slidos?
Yeah. So the first question is there an example of Redis and hybrid search? For example, BM25 plus semantic search that we can try?
Yeah, absolutely. So I would look at that enterprise notebook that Colin and OpenAI put together. It's OpenAI Cookbook apps and then enterprise search or enterprise something, mostly because it's the full app. But if you just want like a Jupyter notebook, you can go and look at what my team has been doing in the OpenAI Cookbook as well. And it's like examples, vector databases, Redis, I think it is. And there's Q&A, there's using JSON, there's hybrid. And if you don't like any of those as well, you should definitely check out Redis Adventures, just the GitHub organization, because everything my team's done is there. And even the 2 apps that I mentioned, which I may have included on here. Oh yeah, here we go, bang. So I should have pulled that one up. That's the GitHub repo. There's a Q&A example, but also the product search, which is the e-commerce link, and then also the doc search one, both have examples of that hybrid search where, like, for instance, on the archive search one, archive papers, we, filter by year or by a category of the paper. And so that's going to be filtering the recall set, or excuse me, pre-filtering the recall set. So filter recall. Yeah.
Do you also have any advice for developing with Redis locally for speed?
Yeah, Redis Stack, Docker run Redis Stack, Google Docker Hub Redis Stack, super easy. And unless you're AWS and you're going to host Redis Stack as a service, you can get started with your startup on just Redis Stack. If you maintain that in the beginning, slap it on an EC2 instance, you can get rolling. And some people do that. It gives you the option to upgrade later. It's great. That's why we do what we do with Redis Stack. So, seriously, just Docker run that Redis Stack example. If you go and look at some of like the Q&A and whatnot, you'll find Docker composes on Redis Ventures. You'll find those Docker compose examples that allow you to just Docker compose up. It'll bring up the Jupyter notebooks. You'll be able to just use it. And one thing that's nice about Redis Stack that you should know is that when you do that Docker run and you open those ports, it's going to start Redis Insight, which we've been putting just a ton of work into. And it's a lot better now. And you'll be able to see everything like hash, JSON, et cetera, in the actual database and be able to click through and edit values. And it's a really good GUI. So it's kind of like peering into your database. You no longer have to just use Redis CLI. And thanks to all the people saying thank you. Good to see you, Eugene. Yeah, appreciate it, Dan. But yeah, so that would be the best way to get started locally. Just Docker run Redis Stack. It's also an app. I think you can just install it bare. If you just yum get it, I'm pretty sure that you can do that as well. We have examples in Google Colab where you just run it all in Colab and install and run it in the background in Colab, which I'm not sure if you should actually be doing, but you can do that as well.
Awesome. I know we are at time. We're slightly over time. So now we have a couple choices depending on your preference, Sam. So one is we can take some of the rest of the Slido questions offline, or if you're willing, we can continue to do this. I think there's around.
Yeah, sure. Let's do a couple more. Let's do a couple more.
Okay, a couple more.
All right.
Perfect.
Yeah. What's the difference between long-term memory and context augment? I feel they are both similar.
Yeah, so they are. Absolutely. The difference is one is more static and one's meant for more of an interaction-based experience. So in the context retrieval, you're usually not updating that contextual database that's filled with your documents or what have you every time the user interacts with the service. It doesn't have to be necessarily dialogue. But when you use long-term memory approaches, every single message is actually being created into an embedding and then put into the database specific for that user. And so that user's interactions are actually stored per that user. Whereas in a contextual retrieval setting, it's really more like one big knowledge base for all of the users of the service. But they are similar. I mean, yeah, they do essentially the same thing. It's just a different system.
How should we think about LLM caching? What types of queries
save
can
money,
we cache?
speed it up. Sorry, what did you say?
Save money, speed it up. Sounds good.
Yeah, that's what it's meant for. Instead of just direct hashing, think like MD sum, those things where it's like, say if I have 1, 2, 3, 4, 5, and I do Python, the hash function, hash, and I hash that. The only thing, you may have a hash collision depending. Let's not get really specific here, but the only thing that's going to hash that same thing typically without a collision is 1, 2, 3, 4, 5. But if I have 1, 2, 3, 4, I actually, in some cases, may want that value because I think it's semantic, or that, semantically or visually or what have you, similar enough because of the embedding representations to actually return that same question or that same answer rather. And so that's really the purpose of semantic caching. And if you have more questions on that, definitely, you know what, I'll just put my email in here. Definitely feel free to email me with those questions, because if you're like, I want to check out, I want to pilot the NVIDIA stuff, or I want to check out, the caching, just hit me up. Happy to answer questions.
All right. And last question here. What resources on vector databases and LLMs do you recommend?
Yeah, so there's a lot. Chip has some great ones, so check out Chip's blog. Chip as a person in general is really great. And if you follow people like Harrison Chase, follow people like Jerry Liu or Simba Cotter, who's getting into the space, and also check out the Redis Ventures repo, the OpenAI cookbook. And also there's this thing called the Redis AI resources list, which has a lot of them specific to Redis, but it's actually, a really good place in sometimes to start. There's also some courses being put out by OpenAI, so check those out. I can't think of other ones on the spot, but if you really are interested in the space, you should just come to the large language models and production part 2 event. Last time there were like 5,000 people. We were expecting like 1,000. And when I say we, I mean MLOps community. I'm just a part of that as well. There were like 5,000 people that came, and this time's supposed to be even bigger. So definitely go check that out. That will be a really informative talk. Like, you have people like Matai, who founded Databricks, coming, or help. He's the CEO or what have you. I don't know. But you have a lot of heavyweights in the space coming to talk at that. So, and not to consider myself one, but I am also talking at that. So you should absolutely come through to that event. It'll be a really good one.
All right, thank you. And thank you everyone for joining us. And thank you, Sam, for presenting.
Yeah, of course.